In January 2005, NASA launched a unique space probe, its mission to find out where water on Earth actually came from. This probe, called Deep Impact, traveled a staggering 270 million kilometers before reaching a comet. Hidden within this comet were secrets humanity had been searching for over centuries. In the entire universe, Earth is the only known place where human beings can live. It seems as though Earth was made just for us. It has everything necessary for life: water, food, and oxygen. In this vast and giant universe, there may or may not be another planet like Earth. But for now, this is the only one we know where life is naturally sustainable. However, 5 billion years ago, Earth didn't even exist. The place where Earth and our solar system currently resides was just a part of the edge of the Milky Way galaxy. Back then, a massive cloud existed in its place, a cloud filled only with dust and gases. So how did this cloud transform into the planet we now live on? This dust and gas cloud is called a molecular cloud. It contained particles like sand, silicon, and different types of metal. The origin of this cloud can be traced to the death of ancient stars. In the early days of the universe, stars that had used up all their fuel exploded, their particles scattered across space, forming this huge cloud. It wasn't a typical cloud you'd see in the sky. It looked like something only visible through powerful instruments like the Hubble Space Telescope. Amazingly, this cloud was about 100 light-years wide. To understand its size, consider this: light would take 100 years to travel from one end of the cloud to the other. This means it was around 6 million times larger than the distance between the Earth and the Sun. From such massive clouds, stars and planets are born, all thanks to one force: gravity. Gravity doesn't exist in a physical form but is generated when two objects in space attract each other. The more massive the object, the stronger its gravity. Inside this molecular cloud, particles began attracting one another. Larger particles pulled in smaller ones. As these particles collided more and more rapidly, energy was generated, heating the core of the rotating cloud for millions of years. This process continued. The core of the cloud grew larger, spun faster, and became hotter, eventually turning into a giant fireball, our Sun. The remaining cloud matter began orbiting around the Sun. The gas and dust in this leftover cloud eventually formed the planets, moons, and possibly life itself. But how exactly did this transformation take place? The idea first emerged in the 1700s when German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace proposed a hypothesis. However, it was only an idea back then. Between the 1920s and 1950s, advancements in telescopes allowed scientists to observe deeper into space. But even that wasn't enough. It was only in the 1970s and 80s, with the invention of radio and infrared telescopes, that scientists could finally see inside these dense clouds. They observed stars forming inside molecular clouds, confirming that new stars are indeed born within them, and leftover particles later form planets. Still, a big question remained: how does this entire process actually begin? In March 2003, an experiment aboard the International Space Station offered a surprising clue. Astronaut Don Pettit conducted experiments with various materials to see how they behave in space. He created water bubbles, dissolved rings in them, and spun plastic bags filled with salt. While the experiment's original purpose was different, the final result answered a centuries-old mystery. In space, salt particles inside the bag began sticking to each other, showing how microgravity causes small particles to attract and clump together. This demonstrated how tiny dust particles in a molecular cloud could begin joining together, just like the salt in Pettit's experiment. About 4.5 billion years ago, similar clumping occurred inside our molecular cloud. As the particle clusters grew to about 1 kilometer in size, they began developing their own gravity and started attracting more materials, just like a vacuum cleaner sucking in dust. Over the next 3 million years, this process gave rise to 20 planet-sized objects orbiting the Sun. However, as these objects grew larger, their gravitational pull caused them to collide with one another. With each collision, two objects would merge into a single, larger one. Over time, the number of planets reduced to just a few, including Venus, Mercury, Mars, and our Earth. But this early Earth was nothing like the blue and life-filled planet we know today. It was a molten, fiery mass due to the intense collisions. Even as Earth began to cool, it still faced a major threat: solar storms. These are powerful radiation bursts from the Sun that can destroy planetary atmospheres. It's one of the reasons why life didn't evolve on nearby planets like Mars. So how did Earth survive? The answer lies in Earth's core. As Earth formed and heated up, heavy elements like iron and nickel melted and sank to its center. Scientists believe that when molten iron spins, it creates a magnetic field. Because Earth has a large molten iron core, it generates a protective magnetic field known as the magnetosphere. This magnetic field shields the planet from solar radiation, especially on the side facing the sun. At the poles, the field is weaker, which allows some particles to enter and interact with the atmosphere, creating the beautiful aurora or northern and southern lights. Fortunately, this radiation is harmless. Still, even with protection from solar storms, Earth wasn't yet ideal for life. It faced another massive challenge, a planetary collision. We know about this event thanks to missions like Apollo, when astronauts brought back rock samples from the moon. Initially, scientists thought the moon was a chunk of Earth, but analysis showed that while oxygen isotopes in moon and Earth rocks matched, the moon's surface appeared to have been superheated, suggesting a violent origin. That violent force was the collision with a Mars-sized planet called Theia. When they collided with Earth, it released immense energy, scattering molten debris into space. These fragments eventually coalesced into what we now know as the moon. Initially, the moon was much closer to Earth, about 15 times closer than it is today. Over time, it has slowly drifted away at a rate of about 1.5 inches per year. This collision had two important consequences. 1. It created the moon. 2. It tilted the Earth on its axis 23.5 degrees, which gave us seasons. Because of this tilt, the amount of sunlight different parts of Earth receive changes throughout the year, resulting in summer, winter, and monsoons. These seasonal variations allow for diverse crops, colors, and climates throughout the year. The moon's gravitational pull also creates tides, which help distribute nutrients in the oceans vital for marine life. But here comes another big question: where did Earth's water come from? This has been one of the biggest scientific mysteries. In January 2005, NASA sent the Deep Impact probe to a comet called Tempel 1, about 270 million kilometers away. The probe carried a 350-kilogram copper impactor that slammed into the comet at a speed of 38,000 kilometers per hour on July 4, 2005, creating a massive crater. The light from the collision was analyzed using spectroscopy, revealing that Tempel 1 contained water in the form of ice. This proved that comets from the outer solar system carry water. But how did they reach Earth? Experts believe that Jupiter played a key role. As the largest planet in the solar system, Jupiter's immense gravity disturbed the orbits of comets in the asteroid belt. These comets, once moving in perfect circles, were pulled into elliptical orbits, bringing many of them toward Earth, where gravity pulled them in. Geologists believe that Earth didn't have water at its formation. It arrived roughly 500 million years later. This conclusion is supported by the discovery of a mineral called zircon, which forms only in the presence of water. Because zircon contains uranium, scientists can use radioactive decay to estimate its age about 4 billion years, proving water came later. So to summarize, Earth was born from a molecular cloud, collided with Theia, formed the moon, tilted to create seasons, and thanks to Jupiter's gravitational pull, received water from comets. All these events set the stage for life. However, even at this point, Earth was still missing one last essential ingredient. So now it's your turn. Tell us in the comments, how do you think oxygen first appeared in Earth's atmosphere? We hope you enjoyed this journey through time with Zynko. Don't forget to like and share this video. Thank you so much for your love and support. See you in the next amazing episode.